hydraulic machine and hydraulic brakes can be operated with the help of Pascal's law. Simply what you have to say, these are the applications of Pascal law. What is meant by Pascal's law? When the pressure is created in a steady fluid in a container, that pressure is equally transmitted in all directions. That should be what we call Pascal's law of fluids. Very simple. One container it is there, in that some fluid it is there. If you can create a pressure at a part of the fluid, then the pressure what we created, that should be equally transmitted to the remaining parts in that fluid. That is what we call Pascal's law. And to explain the hydraulic machines and hydraulic brakes, we have to remember the another form of the Pascal's law. That is what, in any steady fluid, the points which are at the same height, they can be having same pressure. Clear? Let's go for the now working of hydraulic machines. So dear students, here look here, Pascal's law is there. Whenever external pressure is applied on any part of the fluid contained in a vessel, it is transmitted undimensioned and equally in all directions. The pressure what we have created, that should be equally transmitted in all directions in a fluid. So now children, hydraulic lift. So generally hydraulic lift can be used to lift the heavy vehicles like car, trucks, like that. So by applying the little bit lever, one lever it is there. If you can pull the lever, then obviously the car will lift. One small lever it is there, that should be lifts the entire vehicle. How it is possible? Look here now. The mechanism involved in the hydraulic lift is like this. So children, there is some one vessel or container it is there. In that some steady fluid it is there. Steady fluid is there. And now here in that arrangement, this is the piston 1. What is piston 1? And its area is A1. Clear? And now this is the second piston, that should be having some area A2. Now we can observe here A2 is greater than A1. Clear? So this is the first piston and this is the second piston. First piston has area A1 and second one is having some area A2. Clear? So children, now here look at the diagram very carefully. When F1 force is acting or applied on the piston in downwards. Clear? Then here force is there and area also is there. Some force is acting on particular area. What we call? We call that is pressure. When F1 amount of force is applied on the piston of area A1, some pressure is created. So that pressure is created at this area. According to Pascal's law, that pressure is equally transmitted in all directions. In all directions. So due to that, some force is acting on the here. So to identify that, I am erasing remaining portion colors. So this is the now force. What is F2? Clear? F1 force is applied on the piston and the pressure is created. Due to the pressure, some upward force F2 is acting on this particular piston on particular area A2. Due to that F2 force, the car is going to be height. The car is lifted. Why? Because of force F2. That is the mechanism here. When force is applied on the piston 1, some pressure is created in the water. The pressure is transferred from this part to this part. Due to that, some force is acting on the piston and that should be pushes the piston in upward. Due to that, the car is going to be lifted. Now we have to check F1 and F2 are both are equal or not. F2 is greater than F1 or F2 is less than F1. We have to check. Clear? So for that, again we are going to use the Pascal's law. That is what I am going to say. Here P1, what you have to say P1? What we know? Pressure is equals to force per area. What is pressure force here? F1, and A is what? A1. So this is the equation number 1. This is the pressure created at the fission 1. And here some force is acting on the area A2. That's why here pressure is what you write, F2 by A2. Clear? So according to Pascal's law, P1 is equals to P2. Why? Because these two pistons are the same height. So now this point and this point are the same height. That's why I write P1 is equals to P2 we can write. So now you can substitute here P1, P2 values in the equation. What is P1? P1 is what? F1 by A1. That is equals to here what is F2 by A2. F2 by A2. From that you can write F2 is equals to A2 by A1. A2 by A1 into F1. Clear? So now what you have to say? F2 is so greater than F1 because A2 by A1 into F1. That means what? We are multiplying the some value with the F1. That's why here F2 is more than the F1. So even though small amount of force is applied on this one, there is huge force is acting on this piston. Due to that, car is going to be lifted. This is the mechanism involved in the hydraulic lift. Now we can go for hydraulic brakes. The same concept is there. Almost all we will discuss now. Now let's see how hydraulic brakes can work. Same mechanism. When certain pressure is created in a steady fluid, that is equally transmitted in all directions. That is the Pascal's law. Based on that only hydraulic brake also work. So there is one diagram it is there, children. To understand the concept only hydraulics diagram, actually no need of draw this diagram in examination. Okay, only the first thing is hydraulic machine diagram is important. It is not much important for the examination point of view. Look here, what happened when we applied some force on the brake. Look here, any vehicle, some brake it is there. When we are applying the brake, the sudden force on the brake, so there should be creates force on master piston, exerts pressure on liquid. So this is what we call master piston. This is what? Master piston. Already in liquid is there. When we apply some brakes by pressing some force with some force, the pressure is created in the liquid. The pressure what it is created, that is should be equally transmitted to the for the four wheels of a car, anything, water maybe. Okay. So now at a time when we applied some force, the pressure is created. So for example, to stop the any vehicle at a time, the force must be equally supplied to the all the wheels. By pressing the pedal of the brake, simply the pressure must be created in the fluid. That pressure is equally transmitted to the all the tires equally. So here in the diagram only one tire is there. What's happening we have to see. So this is the applied position brake pedal and force is applied, and this is the what we are saying master cylinder, and the liquid from that liquid is transmitted this direction. So to other brakes we are saying, that means what, here only there is one wheel is there, for remaining also the same element is there. And now here slave cylinders are there. These two are the slave cylinders, and the red color what I am showing there, that is the brake pedals or brake pads, and this is what is axle. What is axle? And this is the large disc. What is this one is the large disc. Clear? When force is applied on that one, the pressure is created and that should be comes to the brake pads. So these brake pads will apply the force by stretching the axle and rim of the. So already this is rim wheel. This is the tire. So simply here there should be capture the or simply compress the rim of or rim, some part of the rim. Then obviously some force is acting on the tires and obviously they are coming to rest. So very simple, some pressure is created, that is transmitted to the slave cylinders, and here slave cylinder is there, but in the diagram you can observe the master cylinder and slave cylinders, but you can feel that the slave cylinder has least diameter, but actually they have more diameter. And the force what we applied on the master cylinder, there should be created some pressure. Due to that, there is large amount of force. Look here, pressure exerts the large force on the large pistons of slave cylinder. For slave cylinder, some pistons are attached. Then the force is increased on the slave cylinders. Then obviously there is more force applied on the tiles, and what we applied more than that. Clear? So there is one simple formula to understand this mechanism. F is equals to d by d whole square into small f. What is small f? The force what we applying the brake pedal or brakes. And now what is d? D, capital D is the diameter of each slave cylinder piston. So these two are the slave cylinders. They have more diameter. But they are very seems to be small compared to this one, but it is not actually right, because the diagram pattern should be like that. But actually they have more diameter than the master cylinder. And F is equals to d by d whole square of F. That means here the force should be increased by the d by d whole square of the applied force. That's why more large amount of force acting on the cylinders. Due to that, there should be controls the tiles through the axial and the brake pads also. So this is the children. That's why when we applied some little force, within the seconds the vehicle is coming to the stop. The reason behind that is this only. Okay. So this is simply children about the working of the hydraulic lift and hydraulic brakes. Dear students, if you can understand this one, like, share, comment the video, and if any friend of you they require some physics in a easy manner, then suggest our channel to get the all topics. Okay, thank you for watching.